So, welcome to my dear students and learners. First of all, before starting the today's topic, because today is Deepavali, so my wishes to you all that this festival bring a lot of color and brighten and enlighten your lives. Please do enjoy the colorful festival safely. So today we are going to discuss about the algorithm for solar controller. So we know solar, when we are extracting the power from solar irradiation through solar panel, the power will be changing instantaneously based on the irradiation, because the irradiation, the insolation is not always constant. It will vary, correct? But my load is constant. So suppose there is the load for certain instant, the load is, because load is constant, correct? So if the load is constant and for a certain instant, if the power of the panel is less, then what will happen? What will happen? So because the terminal voltage, if I am keeping the terminal voltage constant, so what will happen? So basically the current will come down, and this kind of will be happening, and for that we will be not able to extract the maximum power. If you see the curve, I'm not going to tell all the details because I am going to explain mainly on the algorithm. So hope who are dealing with solar system, they are well aware about the characteristics of a solar panel. So always our target should be whatever may be the irradiation. So I'll be able to extract the maximum power from that. Whatever it can deliver, let us extract that. So the conventional technique is perturb and observe method, P&O. We all know that. So there what we will do, we will every cycle we will be calculating the power, means we are capturing the voltage and current, and the product will be the power. So in the next cycle, if the power increasing, then I will see what is the trend of the voltage. If the power also increasing and the voltage also increasing, that means it having more capability. So we will increase the duty cycle so that it can deliver more power. If the power also increasing but the voltage is decreasing, that means its capability is less, so we will reduce the duty cycle. Similar way, if the power is decreasing, okay, that time I check. If the voltage also decreasing, then I will increase the duty cycle. And if power is decreasing and a voltage is increasing, then I will reduce the duty cycle. So this is basically the you can see any because the product we are always keeping constant. We are checking the power, the product of voltage and current, and based on that we are checking the capability, whether we are keeping the that peak. If you see the curve, we are keeping the operating point on the peak. This is our target. If you can do that, then based on the irradiation we will be able to extract the maximum power. So this is the conventional technique. So one step ahead if we go, we will learn today how to implement the same kind of algorithm using a fuzzy system, using fuzzy logic. So already about the very basic of fuzzy logic, some videos are there in my channel. You can browse that. What is fuzzy logic and how to implement a fuzzy system based on the time domain data. Even though we are implementing, but you should have a thorough knowledge about the dynamics of the system. Otherwise, you will be not able to identify the fuzzy variables. You will be not able to properly define the membership functions, which will exhibit some error, and you may get the desired performance of the system. Okay, so I am going to now I will be explaining directly about the fuzzy implementation of this maximum power point tracking algorithm. So as I was telling, to fuzzify a system, so what is the basic block? What is the basic block of a fuzzy system? Even though it is detailed in my lecture, still I am telling you. So this is your fuzzy rule based. This will be your fuzzy rule based. Inside this block only all the fuzzy variables and its membership function will be written, and from the fuzzy variable means the fuzzy input and output, how the fuzzy input and fuzzy outputs are related, that is to be defined, which is called the rule based. Okay, then if we give the input, then based on the fuzzy rule based, the output will be exhibiting. So in this particular example, or in this particular assignment, we have considered two fuzzy input variable. One is change of voltage, okay, that is del V, and change of current. It is not direct measurement of change of current. It is somewhat, I will explain you what is that. So this del V is nothing, because here basically the output of the system, of the fuzzy system, will be duty cycle, because through the duty cycle only I am controlling the output voltage of the converter. So there will be a solar cell which will be connected to a DC to DC converter. Then output of the DC to DC converter will be connected to the load, and the duty cycle of the DC to DC converter will be controlled by this fuzzy system. So this is the fundamental architecture of the MPPT fuzzy algorithm. So the output will be change of duty cycle, del D. So what is del V? Because you see, if you see in my channel, there will be some video to generate the PWM. How to generate the PWM in a microcontroller. So basically that will be done through the timer. And the timer will be running at some certain frequency. That means like our clock, it is 12 to 12 it is running. That means 0 to 12 it is always 0, 1, 2, 3, 4, like that, 12 again 0, like that it is going. So similarly in microcontroller also, even though it is for microcontroller it is very faster, so that is called the in terms of power electronics, this cycle is called the switching frequency. So say that I am selecting the switching frequency of the controller is 1 millisecond. Okay, so at every 1 millisecond this duty cycle it will be changing, and while we will be designing the controller, because you need to sense the voltage and current. How to sense the voltage and current? Definitely you need ADC, analog to digital converter. And you know this, most of the microcontroller they are using successive approximation type of ADC. So it have its own conversion time, and after capturing that value, once the conversion is completed, then it will do certain calculations. This also takes some time. After that, the duty cycle will be generated as output. So this will actually, what I mean to say, this ADC conversion and the internal calculation for the fuzzification and defuzzification, it may take some time. That time should be definitely less than, at least less than the switching frequency of the converter. Otherwise what happened, say for conversion of, say for this example, my switching frequency is 1 millisecond. That means after each 1 millisecond the duty cycle will be updated for the PWM. Now the conversion for voltage and the conversion for current, say it may take a 400 millisecond. On example, it is an arbitrary I am telling, and for inside, after that these things it will come to that fuzzy calculation. So in fuzzy calculation, first it will fuzzify the variable, fuzzify the physical quantity as I define the membership function. Then based on the fuzzy input and output variable, whatever the rule base defined, it will calculate the output, then it will defuzzify. So these things say took some 200 millisecond. So once the value of voltage and current arrived in the ADC channel, and after all these things, ADC conversion and this fuzzy operation, already 400 and 200, that means 600 millisecond elapsed. Okay, it's well and good, because my switching frequency is 1000. Sorry, it is, say it is you can take it is 1 second. 1 second. My switching frequency is, or you can tell my this time is 40 millisecond and this is 20 millisecond. Okay. So no, you can sorry, this is wrong. So this you can, my duty cycle, say you can take it is 100 millisecond. 100 millisecond. So that means at every 100 millisecond my duty cycle will be updated. But for ADC conversion, it is taking 40 millisecond, and for my fuzzy calculation, microcontroller is taking 20 milliseconds, so total 60 millisecond. Well and good, because it is within 100 millisecond. Because once the 100 millisecond elapsed, the duty cycle will be changing. By that time, if all this calculation and the conversion is not completed, then that duty cycle will be blanked, or it will be taking the previous duty cycle, which is wrong. What I mean to say, to design the controller, the main aspect you should find out, you should configure the ADC, and you should see for the fuzzification and the defuzzification, whatever the total time is taken, your duty cycle, that means the switching frequency at least should be greater than that. Otherwise, there will be some error. So this is the basic thing for controller selection. So if we increase, if we decrease the switching frequency, it will increase the harmonic or the power quality will be low. And if I increase the switching frequency, then its time period is less. So in that case, the all the conversion and everything should be done in a faster way. So these two things to be considered, and it is to be optimized to obtain the satisfactory performance of the system. So this is the main consideration to design the controller. Okay. So as in the beginning I told that this will be all this calculation, everything, it will be happening after a certain interval basis. So it's a discrete system. So what is del V? So del V is the present voltage minus the previous voltage. Okay, which you can consider as del V. Then you sense the current. Same way, you sense the current also. Okay, same way you sense the current also. So what is your power? So basically the power is the product of voltage into current. Okay. So what is my del P? Del P should be this present power minus my previous power. So this is my del P. Okay. So now what is my I? Defining one variable I, that is my del P by del P. Then what is my del I? Del I is equal to my IK minus IK minus 1. Okay. Hope it's clear. So first you sense the voltage and current through the ADC. Okay. Then you do the product, you will get the power. Then present power minus previous power, which is del P. Similarly, present voltage minus my past voltage, which is del v. You divide these two, you will get a variable called I. That I, again I will be taking the del I, that means the present minus previous. This del I is another variable, another fuzzy variable. Okay, so in this case we are not directly checking the del I. We are taking the product, and this product will give, is giving the power. This power, this change of power, I am dividing by change of voltage, and I am calculating the change of current. Directly I am not taking the change of current from the ADC. After this calculation we are taking it. Okay, so what is this? First, now we have defined the input and output. The input of this fuzzy system is del I, and del V. Okay, and output is change of duty cycle. Okay, so this column is for del I, and this column is for del V. So for the input fuzzy variable, I am giving one example. Then you can see my fuzzy logic video where you can get the full details. So what is this NB, NS, JD, PS, PB? NB means negative big. NS means these are the membership function. NS means negative small. ZD means 0. PS means positive small, and PB is positive big. Okay, so there are three fuzzy variable. One is del V, another is del I, which are input, and another is output, which is del D, that means change of duty cycle. And each duty cycle having each variable contained with 5 membership function. Negative big, negative small, 0, positive small, and positive big. So now say this is, now we need to define the membership function. Okay, so how to do that? Because there will be five membership function. So this is 0. This is my full range. So this range we can only select after doing some physical experiment of the system, by changing things. We have on, as I told, we need to understand the dynamics, then only we can do it. Say this del V, for del V this is my 0. Okay, say it is minus 1 to 1. Okay, so this is for 0. Now I am coming to positive small. So positive small, say it is going from 0 to 2. Then positive big, it is going to 1 to 3. Then I am coming to negative small. Negative small should be minus 2 to 0. Then my negative big, which is going to minus 3 to minus 1. So these are the 5 membership function for the input variable of del V. Similarly, you have to define the membership function for del I and the membership function of del D, change of duty cycle. Now in the fuzzy system you have to define the fuzzy rule based, because without that your fuzzy system will not work. What rule they will take, based on what they will decide the output. So this is the truth table for that. This is the truth table for that. How we will, what is this basically? So I have shown you how to calculate the del I and how to calculate the del V. Okay. Then if first start with some fixed duty cycle, starting duty cycle, say it is duty cycle is 20. Okay. So if the duty cycle is 20, then microcontroller will start. In the next instant, after going to the next cycle, say there is the del I is negative small, but the power is positive big. So for that, what should be your del D? Your del D should be negative small. Got it? So these all, how many things? These all are 0, all are Z only. So that's not written. So how many in a combination it will come? You see, if the del I is NB and del V is NB, then the del D will be this. So like that, this many combination. So 5 by 5, 25 rule base, 25 rule base we have to define. Okay, that means in the rule base you have to write, if the del is negative big and del V is negative big, then the del D will be positive small. If the del I is negative big and del V is negative small, then also my del D will be positive big. If my del I is negative big but del V is 0, then my del D will be negative big. So this, it is a conventional thing I have taken, but it can be fine-tuned based on the once we will do the actual experiment. Okay, so this is all about the algorithm to implement the fuzzy MPPT algorithm. Once again I will summarize the thing. So this truth table is basically it is the fuzzy rule based, which is written based on the practical experience or after studying the response and dynamics of the system. Okay, so in the fuzzy system, this fuzzy system having 2 input and 1 output, those are the fuzzy variable, and each fuzzy variable having 5 membership functions. One is negative big, negative small, 0, positive small and positive big. Okay, then how this 3 variable, means the 2 input and the output are connected, at what rule they are interlinked. So for that, this is the fuzzy rule based. So in the during the controller design, we have to take the feedback. We have to take the feedback, means we have to take the voltage and current through a ADC. Then you do the product of that, which will give the instantaneous power. You take the present power and you take the difference of present power and the previous power, which will give you the del P. Similarly, you take the difference of present voltage and previous voltage, which will give you del V. If you divide by these two, it will give the change of current. This change of current also you take the difference, that means the present present del v, present del p by del v and past del p by del v, which will give the del I. So that is another variable. Okay, and then you define your fuzzy system based on this truth table or this rule base. Then in each cycle the fuzzy system will defuzzify based on the rule base, and it will exhibit the output physical quantity. Then this will define whether the present duty cycle, whether it's increased or decreased. This is the concept, and this way we will do the simulation. That time we will understand how it will work. So this is all about the implementation of MPPT based on fuzzy system. So you can always ask me your doubt. My contact details will be there in the description box. So I tried my level best to make you understand. Hope it will be useful to you. Once again, my thanks to you all. Thanks for your patience. Have a safe and enjoyable Diwali.